All right, this is the neuromuscular junction. This is where the nervous system meets the muscular system. So let's start by drawing the end of a nerve fiber, also known as the axon. So here we're drawing the end of the nerve fiber, or the axon. And obviously this comes from the spinal cord, from the brain, and it's going to end up meeting the muscle. This is the end of the nerve fiber. What I'm drawing now is the muscle. Now you can see those spaces there on the end of the axon. We're going to fill those in with some things a little later. So here in green are something called synaptic vesicles. These are little vesicles, little containers, round little spherical objects that contain a neurotransmitter. Those little red dots right there are a neurotransmitter. The neurotransmitter in this case is known as acetylcholine. Acetylcholine is what is necessary to bridge this gap, because when a nerve impulse comes, it can't cross over to the muscle. You need a transmitter, a messenger, and that's called acetylcholine. We're going to abbreviate it as ACH. Now you can also see here these little orange structures. These are channels, ion channels. If you remember from chemistry, an ion is a charged particle. And these are calcium ion channels. They allow calcium to come through. The other part of the axon in the neuromuscular junction is something we're going to abbreviate as AP, which stands for action potential. All this is an electrical current, a little electrical current that is present in both the nerve and the muscle. But you see that electrical current cannot pass through the space between the nerve and the muscle. That's why we need a neurotransmitter. So you can see here that the electrical current comes down the nerve. When it comes down the nerve, those little squiggly lines coming down the nerve, it allows calcium channels to open, and calcium enters the nerve fiber, the axon. Once calcium enters the nerve fiber, these little synaptic vesicles, they move towards the end of the axon. And then they open up into that space between the axon and the muscle, and they release their contents. And remember, their contents, that red stuff, is acetylcholine, a neurotransmitter. They release their contents into the space between the nerve and the muscle. That space is known as the synaptic cleft, or synaptic space. So on the top there you have the nerve, then you have the synaptic cleft, and below you have the muscle. This is the neuromuscular junction. Now that acetylcholine is released into that synaptic cleft or synaptic space, and it's got to reach the muscle. So that little purple thing that we're drawing right here, these are receptors. And receptors are kind of like a lock, and acetylcholine is a key. Once that key fits into the lock, there's a little channel there that opens up, just like those calcium channels. So this acetylcholine receptor is next to a calcium channel. Once the acetylcholine ends up in that receptor, that channel opens up. It's an ion channel. So there's acetylcholine, it goes into the receptor. It's like the acetylcholine is a key, and the receptor, the purple thing, is like a lock. And once the acetylcholine fits into that lock, it opens up, and through the channel, sodium enters into the muscle. This sodium creates another action potential, another electrical current inside the muscle. And that action potential continues to build up until muscle contraction occurs in the muscle. Now, we have one more thing to address. And that is this pink triangle is something called acetylcholine esterase. That's acetylcholine esterase. Now, acetylcholine esterase is needed because it takes the acetylcholine and breaks it down. Okay, so this little pink triangle takes the acetylcholine, that red dot, and it breaks it down so it can be then recycled back into the axon and used again as a neurotransmitter. The acetylcholine will not fit through the membrane. There's no way for it to fit through that nerve membrane. So it's got to be broken down. It goes back into the nerve, and then it's reformed into acetylcholine inside the nerve and placed back into the synaptic vesicles. That is the neuromuscular junction.